All right, we should be live. Welcome to this presentation by the Finland Azure User Group. So these are the tips and tricks sessions that we have been having for the last year or so, and these are short 30 to 60-minute events usually to kind of provide the community a bigger voice and for a person in the community to show what they have learned in the last couple of months or lately in general. And Finland Azure User Group, as you probably know, is the largest tech user group in Finland, and you can find us in Meetup or on this YouTube channel. And if you want to speak in these events, feel free to contact me, Pasi Huuhka, through any means you want, so LinkedIn or Twitter, or just send a message to the Finland Azure User Group Twitter. And today we have some data platform news here, so I will let Oskari here take over and continue with the presentation. So have a good one, guys. You are still muted, Oskari.
Thank you so much, Pasi, for the kindly reminder. Good afternoon, everyone. My name is Oskari Heikkinen. I've been building data analytics solutions on Microsoft Stack for over a decade now, done most of it on Microsoft Azure. I would say I've done Azure data projects for the past 8 years now. Currently running my one-man company to help customers optimize their business with the help of data analytics. For the next 30 minutes or so, I'll be sharing my thoughts on the latest, most notable changes on Azure Data Platform. We could obviously spend the entire evening going through every single new feature or functionality there has been lately introduced, but I thought let's see the forest for the trees and rather focus on some of the larger ideas and concepts instead. And to understand where we're now and where we're headed, it's perhaps a good idea to understand where we're coming from. So let's take a step back and understand a little bit of the history first. So I'll start off with a few slides. I would say the first 15 to 20 minutes we'll be spending on the slides, and after that I'll do some demos for the rest of the session. So not to worry, this is not gonna be all slides. This is mostly not gonna be slides. So the brief history of I would say building data analytics solutions, mainly data warehousing, that's where we're coming from. So organizations have been doing data warehousing using relational databases since 1980s. Around 20 years after that, some large enterprise customers started to be in the phase that when trying to ingest and process all of their data in a relational database, that wasn't really a feasible option no more. The data was not fully structured anymore, and also the quantities were growing so large that it didn't make sense from the processing perspective and performance perspective either. So there was a clear need for a new technology, and in 2006 the first version of Hadoop was introduced, bringing that up because that's one of the technologies that was also open sourced and used very widely back then, and until I would say a few years ago. So there was a clear need for data lakes and to store data in a semi-structured format and have those distributed file systems that emerged back then to solve that issue. So the point of data lakes was not to compete with relational databases. Instead, the idea was that those two technologies complement one another really nicely. And one of the patterns that I've seen customers use widely, and which I've been advising quite heavily myself as well, is that the first step is to store all the raw data, all your semi-structured big data into your data lake, then process it into a cleansed and structured format, and then after that, as a second step, you can store that or ingest that into your data warehouse as well. Recent developments have actually taken this even further. Databricks coined the term data lakehouse for the purpose, and currently the situation with data lakehouses, the way I see it for the past year, has been that none of these products on the market are fully quite there yet. That's also why it's super interesting to watch and see how they develop. So I'm talking about products and services like Azure Synapse Analytics, Azure Databricks, Snowflake, Amazon Redshift, and so on. Before diving deeper into data lakehouses, let's take a back to understand some of the fundamental technological changes to see where we're headed. And let's start off with a little bit of cloud. I would assume that most, if not all, of you have seen this diagram earlier, right? So it's generally used to describe the SPI model, SPI standing for software, platform, and infrastructure as a service in cloud computing in general. It's usually used to highlight the differences between these options. Right now, I'm, however, looking at this diagram from a different perspective. So when I started doing data warehousing, we simply didn't have cloud available, and we simply didn't have the cloud services that we have available today. So we were doing everything on premise, building everything from scratch. And in 2014, I was actually able to do my first real big data and data warehousing project on Azure. We did use some platform as a service components there, but due to the fact that some of the services on the platform as a service layer weren't quite there yet. For instance, Azure SQL Data Warehouse didn't exist in 2014. Azure SQL Database didn't have the performance it has today, so we couldn't use that for data warehousing either, and so on. So we had to install SQL Server on a VM back then. But even that was a lot quicker than using or creating everything from scratch in an on-prem environment. And 2 years later, we could do the whole stack in 2016 using mainly PaaS and SaaS services. And also that took the rapid pace of development even further. You could cut down the average project times significantly by using the cloud services. And the idea was that we were continuously moving from 2014, 15, 16, and so on, from the left-hand side, from the on-premise environment to the cloud in the first phase, to the infrastructure as a service, and then over to platform as a service, and even to software as a service, such as Power BI available. Due to the nature of analytics, yes, we do still need to build the applications ourselves, so it's mostly platform as a service, but the way I'm advising my clients is to use the services that are as much to the right-hand side on this diagram as possible. So long story short, data warehousing is built on cloud data platforms today because it's much faster than doing the same thing on premise, and we've seen the shift from left to right in this diagram. But within the fundamental, when it comes to the fundamental changes in the cloud services themselves, this was more or less the architecture back in 2014. the blob storage was the place to store your raw data, and the structure and idea there was that first we have the raw area, raw zone, sometimes called bronze, and then we have silver created cleansed data in a structured format, and then on the gold layer we have the data warehouses and data marts and so on. So these were the components. The data is flowing from left-hand side over to right-hand side in this diagram, and Azure HD Insight was back then used to process the raw data. This changed quite a bit in 2016. We saw the data lakes happening. We got Azure AD authentication directly to our data. We also saw the introduction of Azure SQL Data Warehouse as a backbone for our data warehouses on a scale. And then fast forward to 2018, if you were following what everyone else was doing, quite a few companies made a switch from HD Insight to Databricks. Both of them on paper are platform as a service products, but Azure Databricks simply takes the step further and makes it even easier to manage your clusters and makes it faster to develop solutions as well. So thus the better option for big data processing today. Fast forward 2019, we had the introduction of Data Lake Gen 2, which was sort of best of both worlds when it comes to blob storage, and Data Lake Gen 1. So comes with a cheaper price, but then again, you do have the Azure AD authentication baked in. So super good development on the data lake side. And then in 2020, we finally saw the introduction of Azure Synapse Analytics, so the dedicated SQL pool being the successor of Azure SQL Data Warehouse. And there, what these two vendors have been doing since, we have noticed that we have Databricks and Synapse Analytics on this diagram. This is sort of still my go-to architecture if I wanted to use the best technology available on every layer of the architecture. However, there are multiple ways of thinking about this and the data lakehouse concept as a whole. So how the data lakehouses arrived back last year was with very different visions of how to actually execute, how to build those data lakehouses from scratch. So this is Microsoft's vision in the middle, Azure Synapse Analytics. What you can see here is actually quite a lot of the same technology that was already there. So you do have the SQL engine for your needs that you would traditionally use your relational database for, but then you have your data lake storage and Apache Spark for your big data workloads. And then you have the Metastore, metadata management implemented in a way that these two stores sync their data continuously, so that you can basically pick and choose which analytics runtime you want to use, and there is no need to create or build an integration to move the data from the data lake to the SQL pool, or back just for the purpose of querying the data ad hoc, for instance. So the point here isn't perhaps not so much about the amount of new technology that is being introduced. It's the fundamental change of having all of these under the same umbrella and making them work even better together, having deeper integration between the data lake and the data warehouse. So this is the fundamental idea of the data lakehouse concept. How do you fulfill the requirements of both the traditional that you have been doing previously with the traditional SQL and relational databases, so the data warehousing part, but on the other hand, what if when the amount of data is all the time growing, and what if there are those machine learning needs for you? How do you solve those requirements? And this is the approach that Microsoft has taken with Synapse to have everything built in under the same umbrella and make sure that everything ties in well together. Databricks, on the other hand, has taken a completely different approach. They're not having a relational database for the data warehouse or data mart use cases. Instead, their vision is to build everything around data lake and Spark. So if we look at these two options that we have on Azure for building a data lakehouse, we've had perhaps not so actually, I took the top improvements that I see from the vision perspective, which of these functionalities that have been introduced to both these options have been the most influential from architecture perspective. So Databricks having the strong background with Spark and still relying entirely basically on that one. They have had to implement the new features and functionalities around how could we improve Databricks as a platform for data warehousing use cases. The way people have been used to access the data, query the data with their relational databases. Of course, first step, having the Power BI connector available there in the first place. That was, I think, already introduced last year. But if you've taken a look at the release notes of Power BI, it's actually been continuously updated and improved. I think for the past 6 months, on every single Power BI release notes, you will find mention that the Azure Databricks connector has had a update as well. So that's still improving there all the time to get the data even faster from Databricks and from the data lakehouse directly to Power BI. Then from fundamental perspective, the row level security and column level security are available directly on Databricks. And again, from data warehousing perspective, the single most asked feature, or should I say user experience from a Databricks client, is the fact that their users that are already familiar with relational databases and SQL would be easy to approach, easy to use, so that they could use the SQL as they have been using earlier, and also to have the interactive queries. So making Databricks basically faster, and that is of course done through improving the performance of the execution engine, which is called Photon nowadays, or the parts that Databricks has now rewritten in C++ are called Photon, making Databricks even faster for your typical business intelligence and data warehousing queries. So queries where you use join and aggregation functions are good candidates on queries that will run significantly faster on Databricks using Photon as an execution engine. And the Databricks SQL, again, answering the same need for having the SQL experience for all your data warehouse and BI people available. So today I'll be demonstrating both Photon and Databricks SQL on the demos, because I would say that those are the latest and greatest functionalities. So they just were introduced to public preview, I think, just over a month ago, maybe almost 2 months ago. They've been now in public preview 4. And Synapse Analytics, there has been notable improvements. And as the Synapse is coming from the relational database engine side of things, it has obviously focused its efforts, or a lot of its efforts, to building building better solutions for querying the data lake as such. So new and improved, faster Spark runtime available. Delta Lake support has been recently introduced, as well as Synapse Link for ingesting data from Cosmos DB. So I would say those are my top 3 of the latest announcements. With that being said, let's look at some of the Databricks stuff, so Photon and Databricks SQL. So let's hop over to demos at this point. So first of all, to kickstart things, I've already created 2 clusters, the other running on using the Photon as an execution engine. So the way you do it is actually under the Databricks runtime version, you just add the tab here. So with that, you get the Photon for your execution engine, and it will sort of limit the different runtimes you will have available, but also the different kind of hardware that you can use. So there's very limited VM types currently available for Photon use cases. So currently, that's one limitation in the preview phase. But also another significant thing you should have a look at is the fact that this Photon cluster, although I have the same configuration here on the left-hand side as I do on the right-hand side, you'll notice that on the same hardware, the non-Photon costs you less Databricks units per hour, means that the Photon cluster is actually more expensive for you. So next point will be to have a look at how to identify and actually verify that the Photon you are paying for, you're actually getting the value, your queries are actually able to use the functionalities that have been currently built into Photon. So to set some expectations, not every single feature that is on Spark is available on Photon, but the Photon will use Spark as a fallback plan. So in case the Photon library does not actually include the functionality you're looking for, it will still work and run on Spark as it has been doing previously. So to save time, I have already 2 clusters configured, so we can have a look at how these run and execute and how to identify the usage of Photon. So let's run super simple aggregation query on both of the clusters. And if we start from let's start from the non-Photon side of things. So let's have a look at the physical execution plan of these queries. So let's go over here and then select the actual query that was run. So this is the physical execution plan visualized. And what is happening is in the first phase, reading a Parquet file, then it's transforming it from columnar to row format for further processing. Then it's calculating the local aggregate, meaning the sum of people fully vaccinated column over the location. Then it's doing a shuffle operation, meaning it's basically shuffling the data over network. So this is a very expensive operation in terms of data processing and performance. And then the results that it has already aggregated on a local level, meaning on every single VM individually, it will collect those and make a final aggregate of all of those results, and then off to visualize that one. So this is how you would read the physical execution plan of Spark. You have the same, if you've been using Spark earlier, you have the same information here in a text format. This is probably familiar for people familiar with Spark. So that's how you find the information that we need. And if we have a look at the same information on the Photon cluster, so let's go here, let's open the SQL side, let's select the query that we run, and you can see immediately that there's a notable difference, because on this execution plan, we're actually having yellow instead of blue. And yes, that means that we're actually using Photon and Photon functions in the boxes that are displayed in yellow, whereas blue still stands for we're using Spark for this specific function here. So the notable difference is, even if you don't understand the execution plan in detail, you can immediately see whether the Photon has been useful in your specific query just based on the color. And the other thing that we see here is the fact that Photon was actually able to do all the data processing in the vectorized column format, and then the format was changed from columnar to row at the end when the query was almost finished, just to visualize the data, whereas the Spark engine did that pretty much on the first step of the execution. So yes, just by looking at these ones, we can immediately see that in this specific query, Photon was very useful for us. So it's generally very beneficial to use Photon if you have your typical data warehousing queries where you are joining or aggregating large quantities of data. According to the documentation, Microsoft currently defines large quantity of data as over 100 gigs of data. That's where you're likely to see very large performance improvements with Photon. In the TPCDS performance benchmark, the Photon cluster has been 2 or 3 times faster than the non-Photon cluster running on the same hardware. So that's sort of the scale of improvement that you should be seeing with this new engine. So Databricks has definitely made significant improvements on the performance part. And then when it comes to SQL, they have introduced this new part of the workspace that you can find under here called SQL. You maybe noticed or maybe not, but when I changed the area from here, there was the logo of basically Redash shown. So Redash is a company that Databricks purchased last year, and what they've done here is that they have taken the Redash's BI product and now incorporated that as part of the workspace. So you have proper visualization options available within the Databricks SQL as well. On the other hand, since we are operating on Azure and we already have Power BI available, Databricks has stated in the previous summits and other occasions that its intent is not to compete with Power BI, rather have a tool within the workspace so that you can easily do some ad hoc visualization of the data as necessary. And the way I see it, they also want to have that as part of their vision, how to have the Databricks as a unified analytics platform that you can do your data warehousing with, but also your machine learning, so MLflow being the tool on that side of the story. So the way I see it as a fundamental part of the vision. And another good demo that I could perhaps show is over on this side. So you can see that we're having the same metastore, Hive metastore available on Databricks SQL that I have earlier defined on the now data science and engineering area of the workspace, as it is called. And we can easily, let's say if we want to do a single query, so we can do a select, and we can do it from let's say the bank table, and there as well is then we could take the, let's take the count of so let's have job there, and then of course in the group by function I will need to define that as well. And there is really neat format query functionality as well, which ensures that your code is formatted properly, and then you can just run the query against your data lake as usual. So this is my normal query. Query has no results. I wonder if I have any data in that specific table. I guess not then. Or do I? Yes, I do. It just took a while to execute. Okay, now the results are here. Great. So just a demonstration of how it works. And then what you have available as well, which is really neat from performance perspective, is the query history. So you can see all the queries that have been run against the cluster. And this doesn't just apply to queries that I run here locally. This also will capture queries coming in, for instance, from Power BI. So you can easily see which queries take longer period of time and which could be improved in one way or another. SQL endpoints is how clusters are called on Databricks SQL. You can just create one. These are basically named after t-shirt sizes, meaning 2XS being a cluster with only one VM, and then doubling on every single size increase. So 1, 2, 4, 8, 16, 32, 64, 128, and the largest having 256 VMs running there under the hood for you. And the difference is here is that instead of, when I'm creating a SQL endpoint here instead of a cluster, the way I've been sort of familiar with Databricks earlier, I actually can get the load balancing. So if I'm actually using this as a backbone for my Power BI queries, I can have multiple clusters serving those queries under the hood. So that's sort of one of the key new functionalities. Other than that, this creation of SQL endpoint has been made just as easy as possible. So a lot easier, fewer things to define when considering creating a cluster on Databricks workspace. And you can see that the photon is enabled on this side by default. So to wrap it up, the Databricks SQL as well as the Photon are currently in public preview. They've been in public preview, I think, more or less 6 weeks now, give or take 2 weeks. And highly recommend being aware and playing around with it and understanding the use cases where you can actually use it. And to summarize, the good candidates where you could use it and use these options are where you're building your data warehousing and BI solutions directly on top of Databricks. So what is actually happening in this big picture, if we go back to the one of the architecture slides that I showed, this one is that Databricks is trying to have all the functionalities available so that you could also build the gold layer on Databricks, whereas Synapse is trying to help you with the Spark cluster so that you could actually do the data processing on your data lakes, meaning the bronze and silver layers here as well. So I would say that if you have a really easy use case for your data warehousing needs, but a big data lake, then you could very well have just have Databricks for that use case and have everything solved with it. And the other way around, if your data lake architecture is fairly simple, but your data warehousing requirements are super complicated, then you may be able to build the whole thing just using Synapse. So there are situations where you could build the whole thing using either one of these options, depending on your actual use cases. But if you want the best of both of the services, then you would be using Databricks for data lake part and then Synapse for data warehousing at the very moment. So this is sort of the big picture and where I see that data platform and data analytics solutions are currently headed, and where I see that both of these services will be improving in the near future. So Databricks introducing a lot of new functionalities for the data warehousing use cases, while Synapse bringing up the maturity on the data lake side of things. So that's to conclude what I had today. Do we have questions? Let's have a look. So maybe close these ones here.
Yeah, at least Yuri has one question. I can read it here. So, do you know if it's possible to access Databricks Hive Metastore from Synapse Analytics and vice versa? Access Synapse Analytics Hive's Metastore from Databricks side? Or ultimately, is it possible to define external common Hive Metastore for both Synapse and Databricks usage?
That's a good question. I can tell you what I've done. So when Databricks became to be the go-to tool for big data analytics, I found a way to configure an external meta store for your Databricks clusters. So I had a configuration where I had one meta store for all of my HD Insight and Databricks clusters. So technically, you can configure the Databricks side of things there. I haven't actually tried whether you could do the same on Synapse side of things, so can't give you a yes or no definitive answer to that. Would need to see and try it out whether I can force it to do that. But knowing that the way the Synapse currently works is that it's syncing the meta stores under the hood between the SQL pool and between the meta store that the data lake builds. I have a funny feeling that that will cause some issues when trying out that configuration. So that's my first thoughts on that one. Great. Were there other questions?
No other questions in the chat, at least right now. So I suppose we can start wrapping this up. If you want to contact Oskari, you will find his contact information in the description of this video later on. And thanks, Oskari, for presenting, and we'll love to have you back next time also.
Absolutely, fantastic. So feel free to reach out to me. My contact details are available on my website. So that's my phone number and that's my email address if you have any additional good questions regarding how to build data platforms on Azure.
All right. Thanks everybody for joining, and join us again in roughly 3 weeks when we'll have the next session. Keep an eye on Meetup to find out more about that. Thanks.
Thank you.